The paper that's coming out in Nature is a collaborative effort led by a Dutch ecologist named Laurens Porter. And what he and Frans Bongers and Danier Rosenthal have done is to collate data sets and get researchers from across the neotropics together to be able to look at how succession proceeds, how forests regenerate after agriculture or pasture or other land uses, and how quickly that forest grows back. And so my work in secondary forests has been in central Panama, around the Barro Colorado Nature Monument. And I've been collaborating with a woman named Daisy Dent at the University of Stirling in the UK, and my former PhD advisor, Julie Denslow, who the three of us have been looking at secondary forests of different ages using what's called a chronosequence approach. So here's a patch of land that is 20 years old, here's a patch of land that's 40 years old, here's one that's 70 years old, here's one that's 100 years old, and here's where we think the forest has not been disturbed for a very long time, and we'll call that old growth. And we infer, or we use these different places, spaces on the landscape to infer what would happen over time. So we think that the 40-year-old forest is what the 20-year-old forest would look like 20 years from now. So we can take this chronosequence approach and say, okay, this is what the 20-year-old forest would look like, here's what 40-year-old forest looks like, 70, and so on. And what this paper does is to collate lots of chronosequences across Central and South America and ask, how quickly does the forest regain its biomass? So how big are the trees? And ultimately we'll be asking, how much carbon do they store? And how quickly do these forests in these different areas that have different climatic regimes and different soils, how quickly do those forests get the carbon back? How quickly are they sequestering carbon, and how quickly do they get to old growth levels?